Okay. Hello, everybody. This is Aaron Rosari. Back to you for our second week of discussion. So at this point, you should have completed the reading question set number 2 on John Searle. What is it like to be a bat? And you should have uploaded those to Canvas by Thursday night. And again, basically checking those out, making sure you got into the text, tried to discern a few things. And then instead of giving individualized feedback, what I do is I supply my own answers to the questions. And then I do a little video like this, which is designed to give you a, like a second exposure to the gist of the philosophical problem we're discussing. Okay, so John Searle, he's addressing the question, can computers think? And by a computer, if you remember from your reading questions, he has in mind a digital computer. And a digital computer is, you're all used to them, you use them all the time. To my knowledge, I think every computer ever made thus far, though probably not all possible computers, are digital in nature. And the key is, here's an important piece of terminology. So in Searle's article, he distinguished between the semantics of a term and what he calls the syntax of that term. Okay? Computers are syntax driven. So all they do is they're programmed in such a way that when they receive a specific input, train of ones and zeros, or little switches actually, are set up to produce a certain output. So for example, if you were to be using Microsoft Word and you were to type in, I'm studying philosophy, you would know what philosophy means. You would know who yourself is, the I in question. The computer obviously wouldn't know any of that, but they would generate those words on the Microsoft Word doc, even though the computer has no comprehension or understanding of those words. So the semantics of a concept or a word or a sentence is the meaning of that sentence. The syntax is just the rules that govern its use, okay? So what Searle wants to show is that any computer, no matter how sophisticated and how complex, is just generating outputs given a set of inputs, but it's doing so in the absence of understanding what any of the inputs actually mean, the semantics, or what any of the outputs mean for that matter. And he's given a very famous argument for this conclusion. This is called the Chinese room argument. And you could use any language that you don't understand, but Chinese, as most of you know, the writing is non-phonetic. Pictures or drawings are used to represent words or concepts. So this makes it, to someone raised learning English, a kind of an especially foreign language. So I think he chose it for that reason. It's easier to picture the person inside the room failing to comprehend the meaning of the symbols. Okay, so here's a person inside the room. You can make it yourself if you want. And there's some buckets of symbols in Chinese. And there's a rule book written in English which tells the person what symbols to use to respond to a different set of symbols that someone else is feeding into the room, say through a window, okay? So this is George. George wants to get answers to questions written in Chinese. So George gives you a set of symbols in Chinese, and Searle makes it clear you don't even know these are questions, nor do you know what topic they are on. You speak English, but you don't speak Chinese. So when you receive the symbols in, you can't interpret them. But what you can do is go to this rule book and look up the pattern of symbols that was just given to you. And the rule book will tell you which pattern of Chinese symbols to give back out. Searle says the symbols that you give back out through the window are answers to the questions you received. And we'll just stipulate, as Searle does, that they're accurate answers. Here's Searle's point. You are behaving like a person behaves when they understand Chinese. You're able to take a complex input in the Chinese language and give a relevant and accurate output in response to that input. But you have no understanding of that questions are being asked, what those questions are, and what the responses are that you're giving. You are essentially functioning like a digital computer. You have a book of rules that tells you what to spit out given what has been given into the system. Okay, now, computers are just like this. So if I were to pull up Microsoft Word, for example, and let's say I were to type in, let's say I was trying to type in mild, but I typed in milne instead, like I added an extra N that I shouldn't have. Word would underline it in red. And if I clicked on it, it would give me a drop-down menu of words that I understand I could put in its place. Like mild would be one, maybe kiln would be another. Now, think of what we think. Word, we might project onto Word. Word understands I made a mistake, and Word is suggesting corrections. Now, of course, in my mind, that's what's going on, because I understand I inputted a word. I can look at it and understand, okay, I made a spelling error, and I understand that these are possible corrections. But Word, as a program, doesn't have that perspective. It doesn't have a concept of a word. It doesn't have a concept of being correct. It doesn't have the concept of a correction. But when you type in this input, there's just strings of 1 and 0s, which cause Word to spit out this output, okay? And of course, if you take away the N, you just have mild, the word goes away, or the line goes away. So Word is artificially intelligent, right? It acts like a being that understands what a mistake is, what a word is, what a correction is, and acts accordingly. But it does so without actually comprehending any of those categories and concepts. When you're in the Chinese room, you're behaving like a computer. You get the symbols, you look at them, just their form, their syntax. And you have a rule that says when you get that input, give that output. Okay. Now, how does this tie? So that's Searle's argument. Whatever understanding or comprehension is, it's not simply an ability to respond to stimuli appropriately. understanding is a kind of intellectual grasping of what symbols or objects in the world are and mean. And Searle's point is, no matter how much you ramp up the complexity of the rules and the subtlety of the response you can give to an input, that's all at the syntactic level. That's just more and more complicated rule following. And none of that is really all that relevant to understanding the semantics or meaning of these terms. Human reasoners, human cognizers, such as ourselves, we can read a string of words or sentences and come to an understanding of what they mean. And we respond to that information because we understand it. A computer can respond to the symbols because it's been programmed to give a certain output in response, but none of that involves postulating that the computer has the foggiest idea what's going on, okay? That is Searle's point. In relation to the mind-body problem, or the what is consciousness problem, remember last week we argued that, or not we, Thomas Nagel, the authors of the book, gave some arguments that things like sensations or colors, mental states involving, say, an experience of red, maybe they're not brain states. Why? Because none of your brain states are red. So your mental state has a property your brain state lacks, so maybe they're not the same thing. Searle is trying to argue that whatever the mind is, it's not what a defender of what he calls the strong artificial intelligence view says it is. So according to the strong artificial intelligence view, the mind is to the brain what a computer program is to a computer. And a computer program simply operates on the computer and generates outputs in response to inputs. Searle is saying that's not what the human mind is like. It's not simply a input-output device that generates results given inputs. It does do that, but it often does that because we, as minds, understand or grasp what the input means. And that's why we give relevant outputs. Searle himself, just kind of tying in with last week's discussion, he's not a mind-body dualist in the sense that he thinks the mind's this non-physical thing, but he has given arguments that mind-body dualists like, the Chinese room argument, because the most plausible thing a mind could be, if it's a physical object, is something like a really sophisticated computer. And Searle's argument establishes, if it's valid, there's a huge literature on this, but it's at least plausible. It's a strong initial argument that whatever the mind is, it's not this kind of simple computer-like input-output device. The mind has the ability to understand and grasp meanings and concepts, and no computer we've developed can do that. And if you understand what a digital computer is, it's simply a machine that has a set of rules that'll generate an output in response to an input. By definition, no digital computer will ever have true comprehension. Of course, Searle leaves open the possibility that we may one day develop a radically different kind of computer. Maybe that'll reason more like we do, but the ones we have thus far are simply the wrong type. Okay. Now, reasonably sophisticated little set of problems. So if you have questions, write me. The discussion board will ask you to simply map out Searle's argument, and I'll state that assignment rather precisely, and I'll go through and I'll give you some feedback on how well you've done. And those of you who post especially informative answers, I'll put a little announcement up and I'll say, go see so-and-so's response. It actually is right on the money. Now, if you did a poor job, I won't put up announcements saying avoid so-and-so. That would be cruel. But this is difficult stuff. And this is a 100-level course. So it's actually okay if you don't quite get it yet. Email me. Set up an office hour if you have trouble. Yeah, so hopefully I'll see some of you soon. And I hope you've gotten the gist of the argument. Okay, so maybe I can just formalize it real quick. So premise one, digital computers operate solely on syntax. They're programmed, there's a series of triggers. When a certain input comes in, a certain output goes out. That's all they are. Premise two, human minds can give complex outputs given complex inputs, but they often do so based on an understanding of the meaning of the input. So we have a case where the human mind is doing something that the computer is not doing, or the computer program more specifically. Conclusion, human minds are not all that like or analogous to computer processings of information. So hopefully that helps. All right, email me if it doesn't.